Good morning. Today I'm going to talk about the ongoing global climate change and how it can be prevented. But before we can get to our current situation, we must assess the causality of this phenomenon. Global climate change, as is suggested by its name, is a change of all climatic conditions around the world. This phenomenon is not uncommon and has been happening numerous times throughout the Earth's history. The major factors contributing to the Earth's changes in climate are the Milankovitch cycles, which include eccentricity, obliquity, and precession, alongside the concentration of greenhouse gases in our atmosphere. The first of the above stated causes for global changes in climate are the Milankovitch cycles. Milankovitch cycles are changes in the positioning of the Earth which impact the average temperature of the planet. The first cycle in the series is eccentricity. The cycle is stated to cause the Earth to change its orbital from a near circle to a highly oblique shape. This, of course, means that the orbital is when it is at its extreme, there are going to be timings of the year that are significantly farther from the sun, which decreases solar irradiance, the heat coming from the sun. The second Milankovitch cycle is obliquity. Obliquity is a change in the axial tilt of the planet. And the axial tilt is at its maximum, which is 4.5, then the average temperature of the planet will be lower, as a lower amount of the Earth's surface is interacting with solar radiation, and vice versa for the lowest tilt, 22.1. The very next and final Milankovitch cycle is precession, which is a movement from the Earth's axis in a 360-degree fashion. This causes the switch of the star, which is northernmost of the planet, from Polaris to Vega, and vice versa over a course of 30,000 years. The change in the orientation of the Earth is comparable to a wobble of a rapidly spinning object, and the change in this aspect of Earth's orientations causes difference in the distribution of solar irradiance at the perihelion, the closest point to the sun, and the aphelion, the farthest point to the sun, causing a smaller portion of the Earth to react with the sun's irradiance. Now that we have covered the Milankovitch cycles, we can cover the impact of greenhouse gases upon the global temperature. Greenhouse gases are gases that are radiation absorbent and insulators. They absorb the radiation from the sun and heat themselves, and heating other nearing gases up too. This phenomenon allows for the maintenance of a constant temperature. The concentration of these gases affect the constant temperature of the world. For example, it is theorized that during the first emergence of algal-based life, the methane present in the atmosphere was converted into oxygen and carbon dioxide through photosynthesis and plant respiration. And as carbon dioxide is worse insulator and absorbent in comparison to methane, the global temperature cooled down to below zero. The reason this is known is due to the examination of highly dated sediment layers displaying a disparity in temperature markers. Example, glaciation marks. This pattern of greenhouse gas loss being directly linked to the global temperature has been observed throughout Earth's history. And it is believed that the fluctuation of greenhouse gases is currently driving the change in our current climate. CO2 emissions from fossil fuels and the destruction of flora is causing a greater concentration of greenhouse gases in our atmosphere. This is leading to the state change of glaciers formed during a previous glaciation period. This can cause a rise of sea level, which can lead to the breakdown of human settlements nearing coastlines near the coastline. In order to curb the effects of climate change, global interactions and collaboration must occur in order to build sustainable response measures.